Alright, so I guess I gotta turn it on, huh? There we go. Alright, now we're rolling. We're gonna finish lesson 4-4. Okay, so we did the stuff with the logs. Any more questions on that stuff from last night? Anybody? Okay, did we clear up any issues there? Alright, so let's look at the next type. What if I have something like this? E to the 2x plus 4 e to the x plus 3. Alright, and it's equal to 0. Now, if I kind of ignore this for a second, ignore what it says, isn't this a trinomial? Kind of ignore the e, okay? Think back, x squared plus x plus c, right? Isn't this in trinomial form? Yeah. Yes, there's an extra x here. You know, this is essentially x squared, x, whole number. Same type of format. So if you have one like this, we really can't just apply a log to both sides or a natural log to both sides, but we can factor this. Okay. So if I was going to factor, be what, 1, I'd have x squared plus 4x plus 3. Sorry, I wrote this wrong. It should be a minus. Sorry about that. All right. So if I have this, if I'm going to factor that top thing, x squared minus 4x plus 3, what's that going to factor to? What is it? Minus and minus, wouldn't it? Yep. So it'd be x minus 3, x minus 1. Agreed? All right, so let's use that same concept here. The only difference is now my x is e to the x, right? So this guy's going to factor to e to the x minus 3 and e to the x minus 1. That's equal to 0. All right, so again, I'm still solving for x. Now I have it down to this point here. I have a factor is equal to 0. Now I have that rule that says if I have two factors that multiply together and they equal 0, one of them must be 0, right? So set them both equal to 0 and solve. So I'm going to have e to the x minus 3 equals 0 and e to the x minus 1 equals 0. All right, so then left-handed one, I'm going to add the 3 across. So I have e to the x equals 3. Now this is just back to like I did last night, right? If I want to get rid of the e, the inverse of e is what, Sodmont? There we go, natural log. So let's natural log both sides. So I have x equals the natural log of 3. And the natural log of 3 is going to be, give you that, 1.1. All right, then on the second one, same process. Add a 1 across, so I have e to the x equals 1. I'm going to natural log both sides. So I have x equals the natural log of 1. Natural log of 1, that was one of our properties from the other day. Anytime you have the natural log of 1, it's equal to what? 0. There we go. X equals 0. Questions on that one? Anybody? All right. 2x minus 8. All right, try that guy. You guys try it. All right, we're talking the Taylor voice. So we're gonna factor this thing. All right, if we want to factor this thing, what's this gonna factor to? Anybody? Yeah. Okay. Good. Then we can set them both equal to 0, right? So e to the x minus 7 equals 0. E to the x minus 1 equals 0. So this guy, take it over. E to the x equals 7. Natural log. That's going to be x equals the natural log of 7. What's the natural log of 7? I agree. 0.94 and 1.94, 1.95, something like that. All right, then over here, e to the x equals 1. Natural log both sides. Well, the natural log of e to the x is x. Natural log of 1 is what? 0. All right, questions on that? All right, so that was just solved by factoring. Okay? So let's move on to another type. Next one, we're going to solve by rewrites. As you can see, we don't have a whole lot of notes today. It's more so just for examples. All right, so we're going to solve by rewrite. Now, again, whenever we're solving these things, what the heck is that? All right, when we solve by using these things and using these properties of logs, if we can get it to a form where we can put it in a calculator, we're in good shape. All right, but if we can rewrite these and never have to put it in a calculator, we're even in better shape. All right, so let's look at this guy. I go to the log of 4 x plus 3 is equal to 2. Now, if you remember back to the very first rule of logs, somebody flip back in your notes for me. To the very first day we did logs. We had a log rule where we were able to go from logarithmic to exponential and from exponential to logarithmic. All right, so this should be 4.2 or 4.3, I believe. All right, right there. Right here. Okay? I think that's it. Yep, bx equals y, and those types of things. You remember those rules? So let's apply that to this right now and rewrite this. So I can retake this from log form because when stuff's in log form, again, like we talked about earlier, it's kind of more of a concept that we don't 100% grasp, right? You know, it's something that we need a calculator for. We need those charts for. If it's an exponential form, though, we can work with that, can't we? We know how exponents work. All right, so where the heck's my pen at? Oh, it's up there. So if I take this and by that rule I rewrite, so my base to my single thing, so 4 squared is equal to my big number. That was an easy rewrite, wasn't it? I just applied that rule for logarithms between exponential and logarithmic form. All right, so what's 4 squared? 16. And then that's equal to x plus 3. Oh, so x is equal to 13. Doesn't get much easier than that, does it? Yeah, that's pretty simple. All right, you guys. Log sub 2 of x minus 4 equals 3. Knock that one out real quick. All right, so when we rewrite it, what do we got when we write it? Give me the rewrite and then the answer. Okay, and then what do you have for final answer? We agree? Yep. I'm good with that too. 8, and then you add the 4 over. All right, so I don't think that one's terrible. All right, let's do one with some natural logs. How about that? So let's go with this guy.
Listen, I thought you were the pro with the mouse, okay?
No, bro, the mouse is way too long.
I was sitting here, I was like, yeah, that's crazy. You're hard.
All right. All right, so we 3 times the natural log of 2x equals 12. Amazing, the smallest things, right?
Yeah.
All right, so this one's a little trickier for us because we're at the point now where natural log, we really don't know how to solve that, right? all we know how to do is put that in a calculator, which that's fine. I mean, that's the only way I can solve it too. It's not like I'm holding anything back from you. All right? There's no fancy rule for that. So I can plug a natural log of 2, but I can't do a natural log of 2x. Okay, so I have to somehow break this out of the natural log. All right, first thing though, let's get rid of that 3 out front. So get rid of the 3. Let's divide both sides by 3. All right, so now I have the natural log 2x is equal to 4. All right. Now, we had that rewrite rule from, did we do it yesterday? Or was it in lesson 4.3? I believe it was in 4.3. You can see it, we did the base rule here. So it was in 4.3. So I can rewrite this and make this guy into, the natural log is just the log base e. Remember that? So we have the log with our sub. Okay, the log base e is the same as the natural log, and the log base 10 is the same as a common log. Right? Remember doing that? Okay, so let's rewrite this guy. So let's rewrite this as the log base e of 2x equal to 4. You with me there? I just rewrote it back to, I took it out of the natural log, put it back into the standard log form. Because now I can rewrite this using my exponential rules, can't I? Yeah. I can rewrite this guy now as sub to the by itself equals the big number. E to the fourth equals 2x. I can solve this guy for x. Divide both sides by 2. And then throw her into a calculator. So x equals e to the fourth over 2. Yeah, it should be second e. And then divided by 2. So we get 27.2. Okay, so I put second natural log. If you look at natural log, the extra above it, and then divide by second. Yeah, I see that some of your cousins don't have it. These ones have it. You have the same one. If you would leave your, hey, if you guys would leave your answer like this, I'm fine with that. Okay, I think every calculator is going to have the log and the natural log, but I kind of forgot about that. Some of them don't have e to the x. If you don't have an e to the x, I would accept either one of these two answers. Fair enough? Okay. All right. There is. Okay. Let me give you guys one to try, and I'll come take a peek at it. Okay. So try this guy. Let's go 4. Wow, that was terrible handwriting. Why do I keep doing that? I keep writing LEH. Anyhow, 4 ln of 3x equals 8. All right, try that guy. All right, so who wants to walk me through it? Volunteers? All right, Taylor. Uh-huh. Okay. Okay, so you divide by 3. So you get x equals e squared over 3. And what's that come out to be 2 on a calculator? 2.46. Okay. Any questions on those guys? All right, one more for today. All right, so last one for the day looks like this. We're going to go log sub 2 of x plus log sub 2 of x minus 7 is equal to 3. Sort of. This category here would be like combo. All right, combo. All right. So back to our log rules. Okay, you can combine your logs here, but when you combine your logs because they're the same base, you have to multiply what's inside, right? So I can rewrite this guy now to log sub 2 of x minus 7 is equal to 3. This would be condensing, yes, correct. Yep. So, with me so far? Yep. Just condense, use the addition rule for logs. All right. So, let's see, from here, what can we do now? Well, we rewrite this. I don't see any reason why we can't, right? I can rewrite this small number to the single equals x minus 7. All right, so now I don't know, I got rid of logs. I still have some exponents, but I can get rid of that pretty quick, right? I mean, the left side is just going to be 8. Now this right side, I got to do something with this, right? Like it's factored, but it's not equal to 0, so I can't set x equals 0, x equals minus 7, except at 8. So let's distribute it. 5x squared minus 7x. Now, still not seeing anything great, but I almost have a polynomial here now, don't I? I almost have a trinomial. Well, what if I get everything on the same side? Set it equal to 0. So I'm going to subtract the 8 over, but I'm just going to kind of rewrite it here. It's x squared minus 7x minus 8 equals 0. Now it's looking like something, isn't it? Because now I can do what to it? Factor it and then set it equal to 0, right? So let's factor this guy. What's it going to factor to? It can't? Are you sure? About minus 8 plus 1. Okay. All right, so it factors to that. So then I have x minus 8 equals 0, and then also x plus 1 equals 0. All right, add the 8 across, x equals 8, x equals negative 1. All right, so I was able to apply my log rules to that one to simplify it. So I condensed it with the addition rule for logs. Then I'd use the rewrite rule. And then from there, I was able to simplify, factor. I was able to find the two answers. Questions, guys? Anybody? Feeling all right? Okay.